Hey there! Let's talk about polynomial identities and operations. Right here we have addition, subtraction, and multiplication. We're going to talk about division later in rational expressions. So for addition, the key thing to note is that you can only combine like terms that have the same exponent, or the same degree. So for this, we would be able to combine 3k squared and 6k squared, which would get us 9k squared. So let's write 9k squared. And since this k has a power of 1, we can just leave it and it would be completely simplified. That would be our answer for addition, 9k squared plus k. Now let's move on to subtraction, which is fairly similar except another component is added. So 4k to the third power minus 5k plus 10 minus parentheses, that's the key part, negative 3k to the third power plus 5k minus 5. And the key thing about this is that since it has parentheses, you have to distribute the negative sign to all these numbers. So imagine this as a imaginary 1. So just like distribution, we'd have to distribute the negative 1 to all the monomials in the parentheses. So let's kind of break this up a little. 4k to the third power minus 5k plus 10. And now here's the key part. We have to distribute the negative sign. So negative 3k to the third power becomes positive 3k to the third power, and positive 5k turns into negative 5k, and negative 5 turns into positive 5. So let's write that out. Positive 3k to the third power minus 5k plus 5. Now we can simplify this just like addition. We can combine like terms, so this and this is 7k, and negative 5k minus 5k is negative 10k. And now 10 plus 5 is 15. Now let's move on to multiplication. 7p squared plus 3p minus 2 multiplied by 3p plus 1. So here we'd have to use something called FOIL, which is first, outer, inner, last. So first we'd have to multiply 7p squared times 3p and 1. This is distributed to all the factors of this polynomial. So let's start out with 3p squared times 3p and times plus 1. So it's kind of writing it as 7p squared times 3p plus 1. And now the next one is 3p times 3p and 3p times 1. So we could write plus 3p plus 1. And now for the last one, minus 2 and 3p and negative 2 times plus 1. And don't forget that it's still negative, so we have to carry that on. So 2, 3p plus 1, and that is our final very long equation. Let's simplify this. So we'd have 21p to the third power plus 7p squared plus 9p squared plus 3p minus 6p minus 2 equals, now let's combine like terms, 21p to the third plus 16p squared minus 3p minus 2. Whew, that's pretty long, but this is our final answer. Now here's one more practice problem, and I'll do it much quicker. So let's draw out the arrows first. For the first term, then the second term. And as you can see, there's more terms here, so there's definitely more work. It doesn't matter which order you do them, but you have to remember that you must do all of them. It's better to do them in order so you don't forget any monomials in the process. So what we're doing here is really breaking them up, making it smaller and then simplifying it. This is a really long process in the polynomial identities, but it's a really key thing here in algebra. And also on the SAT, they will ask you this a lot. So it's really important that you get this down. So now we can combine like terms. So we have 12p to the fourth minus 40 plus 15, which is 25, p to the third, plus 54 minus 50 is 4p squared, 100 minus 30 is negative 70p, and finally plus 60. Now here, let's talk about the polynomial identities. So here are the three main types, and these types are only for second-degree polynomials. So we know that we've seen these types before, but there's different types of formulas that correspond to the types, so then we could see them immediately and see, oh yeah, that's this type or that's this type. So here's some practice problems. Each one corresponds to a special identity. So let's go with this one. 4a plus 3b squared. So that's obviously this one because that's the only one that's positive. So let's look at the formula. So a plus b squared equals a squared plus 2ab plus b squared. So first we square this, the whole thing, including the coefficient. So let's square it. So 16a squared plus 2ab. So 2 times a times b. So 2 times 4a, which is 8a, times 3b, which is 24ab. And it's b squared for our last term. So b squared is 3b squared, which is 9b squared. Now for the next one, this one, let's look at it. So it's pretty much the same thing as this one, except it's negative. And the only difference is that the second term is negative. So let's apply the same concepts. 2a squared is 4a squared minus 2 times 2a, which is 4a, times 3b, which is 12ab. And finally, plus 3b squared, which is 9b squared. For our last problem, this one's kind of different. It's called the difference of squares, and that's because both terms are squared, and what you have to do is find the square root of each term. So a plus b and a minus b equal the difference of squares. For our first term, we know that the square root of 16a squared is 4a, because square root of 16 is a, 4, and the square root of a squared is a. For here, 9b squared, it would be 3b. Now that we know that, it's just the same term twice. So we'd have 4a plus 3b, and 4a minus 3b. And that's all. Thank you for watching, and this has been provided by SATFreePractice.com.